We got 3 practice problems here. You should try to work through them first and then come back and check and make sure you agree. But these are the notes that are online or this video, either one's fine. The equilibrium constant for the reaction, so we got H2 plus I2 yields 2HI. It varies with temperature in the following way. So they give us the Kc is 794 at 298 and that it's 50 at 700 K. Is the formation of HI favorable more at the high or the low temperature? So if we want to make this favored more or less, we want this number to be big if it's favored, so that's going to lead to higher Kc. So the higher Kc is at the lower temperature, so the this formation of HI favored more at the high or the low temperature. It's going to be favored more at the low temperature because that's going to lead to a higher concentration of the product. We want to form HI, which is the product of the forward reaction, so we want a higher Kc value so that it is formed, which is at 298 Kelvin, so lower temperature should be utilized. The reaction of N2 and O2 to form NO might be considered a means of fixing nitrogen. Hey, that's what the haber process is used, to get nitrogen out of the air, so it can be useful. N2 plus O2 yields 2NO. The value of the equilibrium constant for this reaction at 25 degrees Celsius is Kc equals 1 times 10 to the negative 30. Is this a reaction useful in nitrogen fixing? No, it's not, because hey, this is a really small number, so while there's going to be a little bit of this made, there's not going to be very much of it made, and so you'd have to just continuously point it out, which just isn't realistic. You want the forward reaction to proceed so that the nitrogen is fixed and is in a biologically available form. This means we would want a large Kc value so the reaction proceeds. The Kc value is so small that it's not useful in nitrogen fixing to any large extent. So we got a diagram here. I should move that so we can see it. In the diagram shown below, that represents an equilibrium position at certain temperatures for the reaction of H2 plus I2 yields 2HI. H2 are represented by 2 pink dots, I2 is represented by 2 green dots, and HI is represented by a green and a pink dot. So hey, look, I see lots of those. It's almost all of that. What can be said about the equilibrium position in terms of reactants and products and the likely magnitude of K? So hey, it's almost all HI, which is product, so the position is definitely in favor of HI. If you can't remember, we'll go back here. We can write a equilibrium constant expression. This number is really big compared to those numbers, so we'd have a Kc that's large. And that ends that.